Okay guys, my name is Williamson. I'm with Palo Alto Networks. I know you guys just came directly out of another session, so hopefully we'll give you a little bit of time to kind of refocus and get into the next topic. A little bit about me. I do a lot of malware research for Palo Alto Networks, so that means that I get to look at a lot of interesting stuff that comes into our customer firewalls, how people are trying to break into networks, all that type of good stuff. Make use of me as a resource. I'm not a particularly smart person, but I get to sit on a whole bunch of data. So sometimes that's a lot of fun, right? I get to see, what are the trends going on in malware, what are the latest tricks. This talk is about how to avoid the cyber Pearl Harbor. And I'll explain kind of what we mean about that. But before we get into that, I'm going to do the quick little commercial about who Palo Alto Networks is. And I'll get through that as quickly as I can, but I'm kind of honor bound as an employee to have to do that. Been around since around 2005. We've been shipping products since 2007. Now we're the guys that are behind this concept of a next generation firewall. That means something really specific to us. It's not just kind of your normal jargony, hey, it's next generation. It has to do with how we look at traffic. And that will have a really direct impact on this very topic, right? Because what we're really concerned about is making sure that we're getting rid of as many assumptions about how we look at traffic as possible. That means we want to protect our flank as much as we can. So I'll leave this just kind of as is, because I'll explain kind of what it is that we do that's different here. Because if you think of your traditional network security stack, if you go up through the OSI model from layer 2 up to 7, you progressively kind of go through each one of these steps. And at the firewall, you're going to go up basically to layer 4 and 5. Do port and protocol, this guy gets in or not. But then you may have either a blade or a UTM or maybe a separate box for app control, IPS, all those types of things. And what you end up doing is you keep going up through the stack to find out, hey, what's the answer? What's this thing I'm looking for? And the trick is most people apply their signature still based on port and protocol, right? So you get some badness out of this, which is that you start to lose context. You start to do the same work over and over. And even though you're checking the box, you're not kind of putting that all together in one view. What makes us a next generation firewall, and after this I will stop harping on it, I promise, is that we decided to do all of that heavy lifting as the first step. So the first thing that we do, all traffic, regardless of port, we're going to classify it at the application level. And it's going to stay classified at the application level as we do all of our other analysis, right? So whether I'm looking for IPS, I'm looking for anomalies that could be an APT, I'm looking for malware, we're always going to stay in that full application context. So number one, you get to put things together and say, hey, this is connected to this, and this is an anomaly, and it has something to do with this over here. And you also you're in the right place to look for all those threats, right? You don't have to keep going up and down the stack. So that is the thing that at the core engine level, that's what makes it unique. So wanted to get that out of the way because I can't tell you how many times I hear that, but somebody else has a next generation firewall. That's what we do that's different. Okay, plus we do that equally no matter where we go. Whether it's mobile, whether you're at the perimeter in a data center, in a virtual environment. How many of you guys have VMware or virtual environments being deployed, right? Pretty much everybody, right? If you look at firewalls that get deployed or security solutions, you get a subset of the functionality that you normally get with your normal firewall. We have built everything so that you always get that same functionality. That is important, right? That will get exactly to this concept of cybersecurity and why we talked about Pearl Harbor in the title of this, right? Because I don't think it's news to anyone that there is a whole lot of change going on in the cyber landscape, okay? Very sophisticated attackers, of course, but the amount of data that is being stolen is what grabbed me, right? Everybody that works, everybody that works in this space, and I apologize, this is what happens when you insist on not having Java on your machine and your AV uses Java to update. It will pop up and remind you that you haven't installed Java every once in a while, so keep that in mind. But when we're talking about threats, we're talking about the threat landscape and cyber attacks. The amount of intellectual property, whether that's PII, whether that is something that is maybe a trade secret, and trade secrets don't have to be, blueprints, right? We have seen our customers be targeted by nation states, and they are manufacturers of raw materials, right? Not somebody you think there's going to be like spy versus spy type of actors going after, right? But if you think about that, if you know who is buying steel and how much, at what price, you know what those guys are about to do, right? You know something about that supply chain. And we see this happening across all industries. We see it happening to government. And the amount of data and the amount of important things being stolen is kind of staggering, okay? Now, I've gone a long time and haven't talked much about why we put Pearl Harbor in the title, right? And the interesting thing about Pearl Harbor to me is that, yes, it was a surprise attack, but it was a surprise attack that most everyone knew was coming in some way, shape, or form, right? The president, a year earlier, was saying, yes, things have gotten to a point that I don't see a path how we get through this without going to war, right? The week before the attack happened, the Gallup poll talked to the American public, and 52% said, yes, war is imminent, we're definitely going to war. The Pacific Theater was put on high alert and said, war is coming in the very near future, and we prefer for them to strike first, right? I mean, the military guys were saying this is coming, they're going to strike first, right? And yet, still had at Pearl Harbor all the boats lined up like ducks on a pond, all the planes wing to wing, completely unprepared for this attack. So this is kind of the thing where I think the intersection with cybersecurity happens, because we know the threat is out there, right? We know and have had repeated information coming back and saying, yeah, these things are real, these things are happening. The problem is that no one expected that Pearl Harbor was going to be the place to get attacked. Even with some intelligence that pointed to it, people just didn't believe it. Because if you looked at the expansion of Japan, 1895, they went to war with China, took over Taiwan, went to war with Russia in 1905, took over Korea, went into Manchuria in 1931. They skipped over that World War I era where they were fighting with us, so can't give them too hard of a time for that. Then back into China in 37, and then into Indochina, now Vietnam, 1940. Okay, so this pattern, you see exactly where they're going. And there's US-controlled Philippines right there. And not a strategist in the group would believe that they were going to attack anywhere but the Philippines, right? They were focused completely on Manila, right? And of course, this is where the actual attack happened, right? Even though everybody knew it was coming. Yes?
Sorry to interrupt, but is there any way we could dim those lights right on there so we can see that a little better?
That might be a possibility. They're looking for dimming the lights.
Keep the lights on for the video purposes. We're filming right now. I can try to lower it a little bit for you and see if that helps.
Maybe it's just me. I can't see. It's just kind of dark.
Yeah, it's hard
Yeah.
to see.
Yeah.
Washed
We're
out.
not giving us control right now.
We'll see what we can do. Sorry about that.
Okay.
But even though it's kind of hard to see, this was why I think this was kind of an interesting kind of model for how to think about threats in general, right? Because the things that we boiled down to in terms of cyber attacks are true of kinetic attacks as well. And that the core thing is that the attacker gets to decide where they're going to attack, right? Pretty simple. But it's kind of that, ran into, and this is a story growing up of, the kid goes to his first karate lesson, right? And you learn your first move or whatever, where the instructor says, grab your forearm and then you do this and do that. And the kid comes out thinking he knows karate, right? And he goes and tries to, get in a fight, and then like, wait, the guy didn't grab me by my forearm, right? He did something completely different. I wasn't ready for that, right? That's, that is the difference between, are you prepared for all the things the world can throw at you versus, have you prepared for one eventuality? And in a cybersecurity context, this means that, just like we were talking about earlier, you can be attacked on the mobile side, you can be attacked on the virtual side. You can also be attacked in a variety of applications, right? So it's not okay just to say, hey, the threat's going to come in over SMTP and email, or a threat is only going to come in over the web. We have to be prepared for all of that, because attackers are really, really good at finding where the soft point in the security chain is. So we need to build consistency in by design and build that in early on. We also have to assume that anybody who's going to the trouble of attacking us in a sophisticated way is going to try and hide themselves, right? They will both obscure their traffic, they will do anything that they can to stay off the radar, they will try to blend in with the things that are allowed to be on the network. And this is not particularly a surprise, I would hope, right? Basic attackers do this. Attacks are also increasingly customized, meaning you have malware that's not going to trigger any AV signature, right? You have custom traffic, custom attack tools. And the thing that is scary and that is important to know is that this is not just a nation state activity, right? This is something that has become really popular with organized crime and botnets, because if it works for a targeted attack for a nation state, then it works for organized crime as well. And as soon as organized crime picks it up, you start seeing it in mass, right? This is how botnets just behave. So we need to be prepared for that eventuality. And again, kind of leading into that last point, these are not exceptions. This is not rare stuff, okay? So all of you who manage security organizations, there is no way to scale if we have a manual response to every time a botnet burps, right? Every time a web server serving up malware re-images its file, we can't have an incident response guy go have to chase that down. We have to be proactive or we'll just drown in it, no matter how good the technology is. So with that, I'm just kind of putting up a really basic way that we look at the security model, okay? How we look at controlling this problem. And the first thing is, if you're going to have a funnel, and the whole idea with the funnel is that we're going to take a whole bunch of information, a whole bunch of threats, and progressively whittle it down to a very fine number of things that will require some manual intervention. If you're going to start that way, everything has to go into the funnel, okay? You can't say just HTTP. You can't say just HTTP, but not the stuff that's encrypted by SSL, right? You're going to have to look at all applications. You're going to have to look at how much traffic out there is encrypted and how do I deal with that stuff, right? And from there, we talk about reducing the attack surface. Have you guys, does that language mean anything to you guys? A few? I was giving a similar talk to NATO about 2 weeks ago, and I just by habit said, does everybody know about the attack surface? And they were like, yes, son, we know about the attack surface. We're NATO, move on. But this is, the concept of an attack surface is, where are the guys going to hit you, and what risks are you kind of advertising, are you putting out there for the bad guys to attack you? What we mean by this in a cybersecurity context is what applications are in use, what features in those applications are in use, right? Anything that has the ability to transfer files, and there's a lot of things that transfer files, can bring in malware and bring in threats, right? So that is part of the attack surface. We need to figure out, all right, are we going to let all those applications do that? Or can we put in some controls that say, no, we're going to start to pull some of that off the attack surface. Next is pretty straightforward and obvious, I hope. block everything you can, right? If it's bad, yes, we want to block that. That's actually a lot easier said than done, but you do that through IPS, you do it through URL filtering, you do it through looking at malicious DNS queries. The whole idea is you can bring lots of different types of signature technology together to say, we are going to filter out as much of that bad stuff as we can, but we also understand that that's not going to catch everything. There's going to be unknown malware. There's going to be zero-day exploits. There's going to be unknown custom traffic. So we need to be able to test that stuff that we don't know what is. And once we determine if it's good or it's bad, if it's bad, we need to feed that back into the same engine that does blocking, right? Because just being a stenographer of a problem is not the same thing as stopping it, right? Ultimately, you guys are going to scale your teams. You're going to be able to deal with an influx of attacks based on how much you get to block, not how many people you have to hire for incident response, right? So blocking is paramount. And eventually, if we've done our job well with this funnel, there should be very few things that pop out the end. There will be things that are completely unknown. You may be patient zero. You may be the first person on the planet that's seen a certain type of attack. And if so, you need to be able to give your incident response team or your security ops team relevant information to say, hey, go track this thing down. How do I track it down? What people, what users' boxes are affected, right? What are the indicators of compromise that I want to look for on this potentially infected machine, right? Because that is how you will be able to, again, make use of their time instead of having them just kind of chasing their tails, hoping that they find the right log that tells them what went wrong, okay? So very, very simple, very, very high level approach, but this is something that has proven to be very useful, and I want to kind of go through some of the things that we've seen in the wild and how it kind of fits into this model.
Quick question, how much of a performance hit are you going to get on that?
So question was, what kind of performance hit do you get when you do that? We built the firewall for this job. We are founded by people that wrote stateful inspection way back when. They were at NetScreen, Juniper, then here, right? So we designed the box to be a firewall, meaning it has to be bulletproof in terms of reliability, it has to have super high throughput, it has to have low latency, it has to be a firewall, right? So we knew when we had that first step of saying we were going to classify everything at layer 7, we knew what we were getting ourselves into, frankly, right? There's no shortcut for doing a lot of hard math, right? But we built it to do that job. So that job, when we are doing all of those things, we analyze all traffic at layer 7 by default. It's not a feature you turn on, right? That's what the firewall does when it rolls out of bed in the morning, okay? When you turn on all the threat prevention, it cuts the performance about in half. So our data sheets will say, this is a 20 gig firewall, this is 10 gig with it fully loaded with threat prevention. And by and large, that's what they do, okay? So it's a completely fair question, but it's also one that we designed going into, okay? Okay, kind of back to our view of, and this is supposed to be a complicated slide, don't worry that you can't see it, but I'm just kind of saying that what we've talked about what we want to do in this previous slide. Here we need to start thinking about where do we have to do all of this, right? Because over on the left-hand side, you can see a lot of, we're going to have to do it for email, we're going to have to do it for web over SSL, there's a lot of web-based applications, and then, oh, by the way, there's tons and tons of really fairly new applications that are evasive, they can transfer files. By evasive, I mean if they get blocked where they're supposed to be, they get blocked on their default port, they're going to go down and try to find another port that they can tunnel through. They're going to try to find something else that they can hitch a ride on to get through. Skype is pretty good at it. Skype is as good as some of the most evasive malware we've seen in terms of getting back out of the network, okay? And there's a lot of commingling between valid applications and malware, because valid applications, they need to punch through firewalls for a living, right? Nobody's going to become the next Facebook if they can't get across the firewall, right? So just for adoption, just for being usable by end users, they need to get through firewalls. And you see these same techniques being picked up by malware. But on the right-hand side, and I know you guys probably can't see this as well, but up here, this is the virtual environment, right? Very, very good, sophisticated security companies have been compromised because when someone broke into their virtual machine, they had their certificate server in the same area to a system that was facing the internet. So you saw this east-west attack where they compromised something facing the internet and it tunneled over and started stealing certs for very, very sophisticated security equipment so that they could break into somebody else's environment, right? Those are the types of things that we've got to be thinking about. We can't have, really strong security over here in essentially Manila and ignoring Pearl Harbor, right? Same for mobile. I will give a quick talk on this later if I don't run out of time, but this is an area that is completely unprotected for the most part. There's so many Android phones out there. There's so many, when we talk about unprotected attack surface, it's bad right there. Okay. Basically, the thing I've been trying to get to is that we can't even get to the point of talking about controlling advanced threats on the network if we can't control the network. So that's kind of a priority. I've given you just a few stats here, and not to just bore you, but when I talk about non-standard ports, what I was talking about was just that example earlier of if I get blocked on my normal port, I'm supposed to go out port 80. But if I can't get to a web server, then I'm going to go down the line and try to find another port to use. This is not that odd. We see 568 different applications that have this behavior. Okay? This is not just Skype. This is not just BitTorrent. This is becoming a standard application behavior. Tunneling is kind of the same concept, but a little bit in reverse. So now I'm going to run inside of an approved application into the firewall. It's just going to say, yeah, you're part of the stream that I'm already letting through, and hunky-dory. When I say tunneling, people typically think SSL, SSH. There are 260 applications that can tunnel other applications, right? Why? Because if you want to be really popular, if you want to be able to say somebody wants to instant message from my application as a platform, I've got to have a hook to let that instant messaging application that they use run through me, right? You see a lot of those things built in. And then you see things that are dyed-in-the-wool, paid circumventors. They have no purpose in life other than to avoid security. The backstory, I mean, these are interesting applications, frankly. There's things like UltraSurf and FreeGate. We spend a lot of time keeping up with these, and it's kind of a good news, bad news thing, because these applications were originally developed for people that were in oppressive regimes where the government had a firewall and wouldn't let them communicate with the rest of the world, right? Trick is, they work, right? They punch through firewalls left and right, and I've seen malware using UltraSurf without even modifying it, just using it as its proxy and encryption algorithm to get back out to the world. Right? So being able, if you see these on your network, right, it's a dead giveaway. Somebody is intentionally trying to circumvent policy, right? If you see it coming out of an oppressed regime, it's one thing. If you see it coming out of a network you're controlling, or you're in charge of managing security for, it's a red flag. So how do we deal with this? We have this concept that we call the rule of all. That means that you have to deal with all traffic equally. You have to say, if I'm going to go to layer 7 and tear this traffic apart, I need to do it for everything. Why? Because I can't trust what port tells me, right? I can't trust what the port says about the traffic. And as soon as I can't trust it, I have to verify it. I have to know conclusively what it is. So that means that all traffic, all ports get the same analysis. You have to do a lot of decoding, because just because you see a protocol, that could have another protocol inside of it. So I need to rip that protocol open and see what might be tunneled inside. You need to be able to decrypt. And this is a sensitive area, right? I mean, Obviously, you start talking about decryption, people get concerned about personal privacy. The cool thing you can do here is that you can decrypt things selectively and say, I'm going to stay away, I'm never going to decrypt things going to healthcare, I'm never going to decrypt things going to financial services, but I will have an acceptable use policy that says lots and lots of malware comes from Gmail. You can use Gmail, you can use webmail for your personal use all you want, but we have to have the right to decrypt it, right? So that is one of those kind of, you can have a give and take with users to look for those things. And then of course, you've got to really control those methods that the attackers use to hide, the circumventors, the anonymizers, the free gates and ultraserts that we were talking about earlier. One little note on non-standard ports, this is data and something I tell everybody that I run into because no one is talking about it. We did an analysis of all of the unknown malware that we captured over 3 months, and this is coming from customer firewalls, so it's live networks. We're not going to some dark corner of the internet looking for bad stuff. So this is coming in the front door of networks, and we looked at just the malware that had no AV coverage when it was hitting those networks. Meaning we took this sample, we keep 6 fully updated AV vendors, run it against their engines, and they all said clean, it's good, right? The 4th most common application to deliver this malware was FTP. Obviously web was number 1, email was number 2, but dusty old FTP, I don't run into that many security admins that are staying up at night worrying about FTP, frankly, okay? And it was one of the most common sources. We also tracked how long did it catch for the AV industry to catch up to certain applications or certain malware by application. On average for email, they were pretty good. 3 or 4 days, they would get coverage. For things coming over the web, 10 to 12. We searched for 30 days total. The average for FTP was 29 days, right? 97% of the malware that we looked at stayed unknown because it's off the radar, right? Nobody's looking at it. Nobody's doing behavioral analysis of malware coming in over FTP. And that same amount used completely non-standard ports. Never touched port 21, 21, 21, anything associated with FTP, okay? So I just want to put that as an exclamation point that this is the way that the game is played with really sophisticated folks, okay? We've got to be equal across the board. Yes, sir?
I got a question. You keep talking about FTP. There are not many companies just do FTP anymore. It's all secure FTP.
True.
When they do FTP, they just once they're behind bad guy right away.
Oh, right. But you also have a lot of, so the point was most everyone uses a secure implementation of FTP. The point is that a lot of people, even if you use a secure FTP, they may not be able to block normal FTP on a non-standard port, which is why they're doing that, right? Which is, and that's the point, is if you go in and kind of look at how do I identify FTP at the firewall, or how do I identify FTP even at the IPS level, then it's almost always I'm going to apply this signature to this port, right? And that's why they do it. So, and the whole idea for malware is I'm going to infect some, poor end user, and then I own his machine and I can use any port that I want, okay? So, very good question. I'm going to have to skip through a lot of this very quickly, just to make sure that you guys get to the awards and all that type of good stuff. But one thing I want to wrap up with is that there are a lot of applications out there that aren't just good or bad, okay? They aren't the kind of traditional view of this is an okay application, this is not. And I want to give a couple of examples because these are applications, by and large, you're not going to be able to get rid of, right? Remote desktop, RDP, reverse VNC, VNC, these are important things. People use them for good purposes, right? But it's also one of those things that from an end user's perspective, people use RDP to get around the web filter, right? Because an RDP session is going to be encrypted, right? They'll RDP home, and then they'll surf to all the places they're not allowed to surf from work, right? RDP is a favorite tool for hackers APTs, because this is how you can do some very hands-on remote hacking. How many here know of the Mandiant report? You heard about Mandiant? Okay. There was a very, very good incident response guys, analyst folks. They were the ones that kind of blew the whistle and said, hey, we have proof that there are Chinese hacking groups specifically targeting guys in the US, right? And they drew the line back to the Chinese government. The way that they were initially able to find out that these were Chinese hackers in general was because they were always using RDP to remote into infected clients, and they were using a Chinese keyboard, right? So they at least, as the first step, knew that they were dealing with Chinese-speaking people, and then they went from there to find out where they were after that. But RDP was so common, they were able to tie all of these guys together just by looking at the common indicators in RDP itself, okay? So this is important. Why do we harp on this? Because this is one of those applications you're going to have to allow, but you're going to have to put some context around it, right? We can't just have RDP flowing around all the time. There's going to have to be specific users that are allowed, right? There's going to be specific places it's allowed to go, right? So that if we start seeing strange people sending up RDP or having RDP sessions coming from places we don't recognize, that needs to be able to stand out, right? And if we don't get some of those contextual policies in place, it'll be almost impossible to control. File transfer, same thing. Anything that transfers files, hackers use to bring down secondary payloads, okay? Most of the interesting attacks, the interesting malware, the first thing doesn't do much. Its only job is to download more malware, right? More executables, more files. So you'll see lots of things that transfer files being used by bad guys. And of course, we're not getting rid of Dropbox. We're not going to get rid of, secure FTP. And by and large, we're probably not going to get rid of peer-to-peer either, which is a different problem. But this is one of those things that, again, we need to be able to think, how do we safely enable this, right? How do we allow this technology in without necessarily just giving an attacker free reign of the environment? Something that is important, and I'll give an example here in just a second. Another one in this category, web proxies. Who all has a web proxy? Yeah, okay, well, fewer than I imagined. But web proxies are pretty common things in an environment. It's also one of the things that malware brings with it, right? Because malware doesn't like to talk to its real destination. It's going to proxy around different places so that it's hard to follow, right? It's not going to leave a trail of breadcrumbs back to the hideout, right? So this is another one of those examples that you need to be able to know, hey, is this my proxy or something else? Is this something that I haven't seen on my network before? Because if I just let all proxy traffic out, then these guys will just jump right in the slipstream and nobody ever sees it, right? So this is why having some really good fine-grained application control gets critical to solving the problem. And then SSL. SSL is a big blind spot. It's one of those things that I think is really important to be able to handle selectively. We see malware left, right, and center that it doesn't even use SSL. It just sets up an SSL handshake, because most security platforms, if they see SSL being set up, they just say, oh, fast path that I can't see that anyway, right? So you try to decrypt it, it doesn't decrypt because it's not encrypted, right? It's sitting there in the clear, but it's just trying to go to the fast path from security. So one example, TDL4, this is a piece of malware. It got the name for being the indestructible botnet, right? Couldn't be broken. And it did a lot of things that were really cool, but it used pretty much all those things I was talking about in the previous slide. In terms of infection, it was almost all via drive-by downloads, which is pretty common these days. It was a really, really solid rootkit, bootkit. In fact, infected the master boot record so that as long as the system got booted, you couldn't get it off of there. Now, this stuff on the right, the communication, the command and control, that's what got it dubbed to be indestructible, okay? It used its own proprietary encryption, but it then wrapped that in SSL, right? Because it didn't want to look proprietary. look like encryption and one to look like SSL. And then it brought its own proxy with it. It brought its own proxy server so that it could bounce around to any other infected host in the world. The cool thing is that, how many of you guys know about Tor? Kind of the anonymizing network, all that kind of stuff, bounce around nodes. They sold their own private version of Tor using all of the infected nodes, right? Because it's all proxied. They use their own encryption, they could bounce it around, and that was one of the things they did with their botnet. In addition to stealing bank cards and all that kind of other stuff, it was here's a completely clean channel for other hackers to use. For its command and control, it used peer-to-peer. Peer-to-peer is just pay dirt for a hacker because it's meant to be fault tolerant. It's expecting to lose nodes. It's expecting to lose a server. So it's very, very resilient. And then it would proxy through all these other infected hosts. So once you can do that, the question I always got from people was, well, what does it do? Was it stealing credit card numbers or whatever? It did all kinds of things, right? If you can do these things up here, you can infect somebody, you can stay persistent, you can communicate without being disrupted, then you decide what you want to run, right? One day it was stealing credit card numbers, the other day it was launching a DOS attack at other networks, right? So this is the way that I encourage people to think about malware, because that's how sophisticated malware works. That communication platform, the persistence, is more important than the payload, right? Because that's what keeps them alive. That's what keeps them in business. This is a summary. Again, I know you guys probably can't read this, but we'll provide any of these slides that you want. And for anything that we don't get to in the presentation, just hit us up over at the booth, and we'll be able to tell you about it. But these are some of the recommendations that I give to people when I'm out in the field, right? Here are the types of applications you need to control and why, right? Because custom traffic we'll talk about in just a second, but looking into SSL, looking into those peer-to-peer applications, looking into proxies and remote desktops. Those are all things that you're probably going to allow on your network, but you need to really tightly control them. Very few users, very few countries and locations it should go to, very few domains they should be allowed to communicate with, right? What times of day should they be allowed to use them, right? Because a lot of people will RDP in the middle of the night back in to do some additional hacking. And then the anonymizers, the evaders, all those types of things need to be locked down. Lastly, I want to talk really quickly about managing the unknowns. We've talked a little bit about targeted custom malware. This is very, very common. It is not something that is that rare anymore. Probably 3 or 4 years ago, you had some targeted malware on your network. It was pretty interesting and unique. We see this, a handful coming into most networks on a given day, right? Because it's become a technique that more people have figured out. The way that we deal with this problem is, since we're looking at all the traffic, we're breaking it all apart, we can find and see files because we're looking for malware already. If we have a file that is a payload we don't recognize, we can send it to something we call Wildfire. This is our sandbox. We execute it, see how it behaves, right? Learn, does this do bad things or not? And if it does do bad things, then we can, on the fly, create a signature, real malware signature, URL signatures, command and control signatures, deliver them back to the firewall so that you can both block another infection from that file, but just as importantly, you can keep that command and control traffic, that bad traffic coming from the malware, from getting out of the network, okay? Really, really helpful stuff. And also, this is a great tool for doing root cause analysis, okay? Because the really successful people that do security administration that I run into, everything that hits Wildfire, they'll go back and say, all right, I need to learn what the user was doing right before this happened, right? What sites were they on? What applications were they using? What other files got downloaded? Because if I know that, I can start to build good policies so that I get fewer and fewer of these incidents, and that's really important. One last thing, custom applications. one of the super cool things that happens when you classify all traffic at the application level is that we're going to put it through hundreds of decoders. We're going to match it against all the signatures we know. We're going to match it against heuristics. And sometimes things still pop out the other end and we don't know what it is, right? And we show it to you. We say, this is unknown UDP, this is unknown TCP, don't know what it is, right? It is incredibly likely that that is malware traffic when we see that. It's either a custom application that your developers have built themselves, at which point it's easy to write a custom app ID for it to recognize it correctly, or it's malware. And to prove that, we looked at thousands and thousands of people that we did evaluations for, and just looking at the real traffic coming in on their network. Unknown and custom traffic accounted for less than 1% to 2% of the traffic on their networks. It accounted for over 50% of the malware logs on those same networks. And those are known malware logs, right? And this, people always ask me, what are the really good indicators of compromise you look for? There's a bunch. DNS is a good one. Using fast flux is a good one. This one is dead simple easy, right? You pull the thread and find out where all the unknown traffic goes, you're going to find badness on the network, right? So again, this is why, even though I harp on it, I think that looking at the network this way is important. This is just an example, since you guys can't see it. It's just a firewall log, and then eventually I look into that log and it says this program can't be run in DOS mode. This is just letting you know it's bringing down an additional payload. This isn't executable. So a lot of times when I'm looking and searching for bad things in PCAPs, I go and look at the unknown traffic, and 9 times out of 10 I find bad things. Lastly, just to wrap up, mobility. I said I would get back to this. Mobility, and by mobility I mean smartphones and tablets, are being adopted faster than any other technology in the history of mankind. If we look at how long it took television, electricity, anything to be adopted, even regular cell phones, computers, it's off the charts fast at how fast it's being adopted. From an attack perspective, if you have a bunch of very powerful devices, they can do 90% of what PCs can do. They are allowed to do pretty much anything on a network because people can't control them that much, right? They're brought onto the network. The most that people try to do with mobile devices now is try to put a container around some of the data, not really secure them. So if you add all of that up, that is an enormous attack surface. We have already seen lots of malware being delivered through mobile ad networks. So even if you got the application in a completely safe, approved place, you went to the Google Play Store and got it, it goes out, serves up an ad, the ad brings down malware, and it has built a botnet out of using SMS messages as its command and control, right? So this is leading right up to the front door of the networks that you guys all manage, right? Because they're going to be allowed to authenticate to Wi-Fi. They're going to be allowed to go out and get their mail probably, right? So those are things that you need to think about when we're talking about being equal across all those places we're going to do enforcement. This is the next area. So to wrap up, I want to give a little time for questions, but our view here is that this world of applications and malware and threats have become completely mixed, right? The ways that applications evade are the ways that malware evades. We need to have this type of visibility that says, start at the top, look at everything, understand what that traffic really is and what it's really trying to do, then look for the bad things, look for the unknowns, and build that into one integrated process. So sometimes it's easier said than done, and I want to make light of it, but that's the approach. That's how we think about things. And with that, I'll take a deep breath and shut up and see if any of you guys have any questions for me. Anything we didn't get to?
My name's Matt. I work with Wayne. I had a comment. One of the pieces of information that Wayne talked about was being able to protect remote desktop and things like that. We've got numerous customers in the state. We're doing evals as well as customers. We're finding that to be pretty critical. One of the things that we're catching people doing is trying contracted employees logging in from their home, using anywhere, and accessing the database, and either taking proprietary state information and doing whatever they are with it, or doing things like logging into their timestamping applications so they can punch in as if they're already in the office when it's back to their home, logging in. We're seeing this on a pretty regular random basis, so it's definitely something to be concerned about. So I wanted to make a real world example of things that Chris is asking every day. So I want to check the guilty, so to speak, but if anyone's interested in learning more about how we can catch that, I can feel free to call the chart.
Cool. All right. Thanks, guys. I'll be around if any of you have. Oh, yes, sir.
I'll copy that.
Okay. All right. Thank you.